Section 6.7, distance problems. This is the way the problem reads. It says the rate of the jet stream is 100 miles per hour. Traveling with the jet stream, an airplane can fly 2,400 miles in the same amount of time as it takes to fly 1,600 miles going against the jet stream. What is the airplane's average rate in calm air? So, first thing I wrote up here is a distance rate time chart. That's how you want to set these problems up. All right, I've got two categories. I've got with the jet stream and against the jet stream. Okay, the distance with the jet stream, the problem stated was 2,400 miles. Okay, going against the jet stream, which is obviously going to slow me down, at the same speed I'm only able to travel 1,600 miles. Okay, it says what is the rate of the airplane in calm air? Well, when you're talking about the rate, if you're going with the jet stream, it's going to be x plus y. If you're going against the jet stream, it's x minus y. Now the question always is, what is x and what is y? Well, your x is always the rate in calm air or still air. A lot of different words they may use, but it's the rate in calm air. All right, the y is the rate of your jet stream, the rate of the wind, the rate of the current if you're talking about water, anything like that. So that's what you're going to plug in. Well, what's the only one we know? The only one we know is the rate of the jet stream. That's what we're going to type in, which is 100. So this then becomes x plus 100, and then this is going to be x minus 100. Now that should make sense. If you're going against the jet stream, it's going to slow you down. That's why you're subtracting. If you're going with the jet stream, it's going to speed you up. That's why you're adding. Now the formula for distance is d equals r times t. Well, if I want to solve this formula for t, I would divide both sides by r. So I get d over r equals t. Okay, so in doing this, that's how you're going to set up the time column, because you technically don't know what that is yet. So I know my distance is 2,400, and my rate is x plus 100. Okay, same thing for the going against the jet stream. Distance is 1,600, rate is x minus 100. So that's my time column. Now this problem states that it takes the same amount of time, which means that this time has to be equal to this time. So how do you set it up algebraically? Well, you're going to set this equal to this. All right, so my problem then becomes, I'm going to come over here for a minute, 2,400 over x plus 100 equals 1,600 over x minus 100. Okay, that is my algebraic equation that I need to solve. All of that comes from this chart. So if you can't set up the chart, getting the equation set up is going to be a little bit difficult. All right, so there's my chart. I'll show it to you one more time. Distance with, distance against. Rate with, rate against. Time is distance over rate. Distance over rate. All right, so now I'm going to solve my algebraic equation. How do you solve when you have two fractions that are set equal to each other? You just cross multiply. So I'm going to do 2,400 times x minus 100 equals 1,600 times x plus 100. Okay, then I'm going to distribute. So I get 2,400x minus 240,000 equals 1,600x plus 160,000. Okay. And now what? Well, now you've just got a multi-step equation where you've got to get the variables on one side and the numbers on the other. So my larger variable is 2,400. So I'm going to move the 1,600 over here to get with the larger one. So now I'm going to subtract 1,600x from both sides. All right, this gives me 800x minus 240,000 equals 160,000. Since I chose to move the x's to the left, I'm going to move the numbers to the right. So I'm going to add 240,000. All right. Now I have 800x equals 400,000. Your last steps, divide by 800. So I get x equals 500, miles per hour. Okay, that is the rate of my airplane. That's how fast the plane is traveling in calm air.